Okay, let's restart from the last topic of yesterday. We introduced the whole framework. We start discussing DID, DID document, the relation between DID and DID documents. And then we arrive to the CRUD operation: create, resolve, update, delete, or deactivate, based on the VDR that you select for building your identity. The R stands for resolution, and this is the template of the general resolution function that is common to more or less all the DID method. Just to recap, the resolve requires two inputs: the DID, that is the entry for the resolve to interact with the VDR and retrieve the associated DID documents, some options, and we receive back DID resolution metadata, of course, the DID documents, and some more metadata that are associated to the DID documents. Let us just review the different properties. DID, some options. Normally metadata are in structure that you predefine and receive back from the function, the DID documents and some metadata. Now, DID resolution options accept the media type that the caller's preferred representation of the DID document typically is a JSON file. Expand relative URL as a simple Boolean flag to instruct the resolver to expand or not, relative URL to absolute URL, version ID and version time. These are the specific version of the DID document to be resolved. I want exactly that version, and or I can set the version time, so the timestamp of the DID documents to be resolved. The metadata, super simple. The content type, it is the media type of the DID documents, and the classical structure for handling errors. The DID document is the DID document. The metadata associated with the DID documents, essentially created, that is the timestamp of the create operation. Updated, the timestamp of the last update operation on the resolved documents. Deactivated, set to true if the DID has been deactivated. This can happen, of course. Next update, the timestamp of the next update operation, if and only if, typically, if the resolved DID document is not the last version. This means that the resolver and the combination between the resolver and the VDR must be clever enough also to know exactly all the different updates on the DID document, and the version ID, the version of the last update on the document resolved. Now, let's do two simple exercises on that. That's why I prefer to recap a bit the the last topic of yesterday. And today we will do one more exercise on the ID document, just to recap, and then some simple exercise on DID resolve, essentially to understand correctly based on which kind of DID I present to the resolver, what is the information I'm referring to for resolving from the document. So let's do. Let me stop sharing. Okay. You can reuse part of the exercise already used yesterday. So we want a DID document with two general verification methods. So we don't use authentication, but the properties verification method. We can make a vector. Okay. And let's make also, oops, close here and close here. Okay. Now let's make it a bit more specific. First ID. We have also to change here. Let's, for example, use the example DID method, the specific ID 123 ABC. Good. Now, in the verification methods, I use the fragments such that I can refer to which of the two methods I need. So I use again the same name for the DID, ABC, key 2. So we now have DID documents that provide any resolver the right information on the context, of course, the root ID of the documents, essentially the DID of the controller of these documents, and then two verification methods, multi-base encoded, and let's also specify the controller in both. So we are doing an example in which subject and controller coincide, are the same entity. Okay, and we use the fragment hash key 1 and key 2, or any fragment you want. Sometimes is also in some methods use the key ID or the hash of the keys. So it depends on the specific specification and implementation. Yeah. Sure. Multi-key, that, as I told you yesterday, is essentially what the community is using much in the last 2-3 years. Sometimes you find JVK, but I suppose in the next year multi-key will be the only type used. And of course, the encoded public key. Now, let's go to the exercise number 2. And what the exercise number 2 is asking is to use the DID document that we have just defined and to resolve 2 different DIDs. So let's make this exercise. So example. ABC. So what happens if I resolve this DID? What happens? This is the document. An idea? This is the simplest resolution request. I want the whole DID document, and I'm not referencing any specific verification method in it. Okay? So I receive, of course, the whole DID document back. What happens if I specify T1? Let's make it clear here. Of course, the resolve give you back the whole DID document, but in the next step of the resolution process, what you are essentially asking is to receive and to use this particular verification method. So, okay, so every time you receive the whole DID documents, but then with this specific DID, I'm telling my peer that if he want, I don't know, for example, authenticate with me, has to use this specific verification method. Okay? Of course, the exercise is more or less the same if we use key 2. So remember, the resolve operation give you back always the whole documents. If you have already specified also the tag, you can directly point to the specific public keys that you need. Another possible option, you receive from your peer only the DID without the fragments, and you know from the application layer that you are going to enter in a key agreement process. So typically you will resolve the DID, you will get the DID documents, and if the DID document, for example, specify the specific properties key agreement, you know exactly which is the keys that you are going to use in that process. It can also happen that in this specific example, the controller, the peer controller of the DID document also give you information about the service. So where to contact the peer to start the key agreement. Very good. Now, let's back to presentation mode. Okay. So to recap, we addressed the first two layers of the whole SSI framework. The key technologies at layer one is the DID, the centralized identifier. The decentralized identifier essentially identify a DID subject. A DID resolve to a DID document. The DID document describe with some properties. These are not really, let's say, properties that give the whole and rich definition of your identity. It's just one component of what will be your real and final self-sovereign identity. So the DID document describe part of your identity. Beside the DID subject, there is also the DID controller. DID controller typically coincide with the subject. This is not always the case, and we will see some example in few minutes. The controller is the entity authorized to generate and update the DID document. Now, controller can be, in some cases, also more than one. In this particular example, we have three independent controllers that interact each other to control the DID documents. The DID documents, of course, always describe with the properties the DID subject. But in this specific case, there are several entities that must coordinate among themselves to control the DID document, generate the DID document, update the DID document. This means, and this is outside the scope of DID recommendation, this means that in this particular implementation of the identity, there must be some overlay function that coordinate the different controllers. There can be any coordination function you want. Can be, you can order in terms of priority the controllers. So anytime a controller with high priority want to update the document can do it. You must, for example, reach a consensus between the three in this case to make an update or any coordination function that you want to implement. This is just to say that the recommendation give you freedom in terms of who is going to control the DID document. Beside the independent control, in other cases, you can also have a DID controller group, another option. They must be handled. It's not the DID recommendation that tell you how, is your custom specification and implementation that have to deal with it. Okay, now as we addressed yesterday, the recommendation is an open standard that give you some principle for your implementation, provide you the reference for your specific implementation, and also give you some hint in terms of consideration that for the implementer, no, in terms of security and privacy. The DID recommendation defined by the W3C discuss some of these security considerations. Let's go through them to understand better what are the points that we need to take in mind and consider carefully when we decide to implement, specify, and then implement our specific DID method. Not only when implement, but also when you use your DID method. The first one is choosing DID resolver. What does it mean? Essentially, if you remember yesterday, I showed you a web page with 100 different methods, and every single day someone provide a new one. So since there is no central authority in this framework that specify or tell you exactly which kind of specification and implementation has been used by, for example, a DID resolver based on the DID method name that is selected, one point of attention when you interact, you develop the system to interact with others, you need to be careful in selecting the right specification, implementation, or implement correctly your the chosen specification, otherwise interoperability fail. Non-repudiation. Non-repudiation of DIDs and DID documents updates. This is very important because let's say non-repudiation is supported only if the VDR support verifiable timestamp. If the subject is monitoring for unauthorized updates of the DID document, and the subject has an adequate opportunity to revert from malicious updates. If one of these three conditions are not met, you cannot consider non-repudiation feature. So it's very important again that based on your choice of an existing DID method or your specific implementation, you have to consider this point. So non-repudiation is met only in terms of the updates of DID and DID documents only if VDR support verifiable timestamp, the subject is monitoring for unauthorized update. That's very important because not all VDR provide you, let's say, simple way to monitoring, check updates on data anchored to the ledger. And if your implementation give the subject the opportunity to revert from malicious updates. Otherwise, non-repudiation is not supported by this specific implementation. The consideration is notification of DID documents updates or changing. This is really important because in some DLTs, you can, for example, receive an event. No, you can subscribe to some events that are, let's say, in-house of this specific VDR DLT, and you can monitoring these events, and you know exactly when the DID document is when there is a change. In other cases, this option is not available. Sometimes there are some overlay on top of the VDR that provide you this service, but you have to carefully consider, are you the implementer of that service? Are you using a third-party service? What are the drawback of these overlay services? What are the security features? So you have to carefully consider all these points. Otherwise, you can have specified and implemented the best DID method in the world, but you fail because you don't consider all the other features around. That's exactly what this kind of security consideration are meant for us to consider not only the focus, but also what is around, and be sure that what we are deploying is something that is really secure and trusted. Revocation in trustless system. What does it mean? A trustless system means that there is no a priori trust between anyone in the system, people, organizations, objects, whatever. And so a system, let's say, in a trustless environment, trust is derived only from cryptographically provable assertion or proof, digital signature, for example. No, so we don't trust anyone else a priori. We want proof for building the trust. If you remember the DID resolve or create operation, there are also, in many cases, the use of metadata. But what are the level of trust in this metadata? So if we want to implement strong trust in trustless environment, we must not use metadata for taking decision in terms of trust between entities. Okay? DID recovery. DID recovery is really important because if you lose control of your DID or DID document, essentially you are losing your identity. So the requirements lifelong digital identity fail. So what this recommendation is suggesting is to, in a proactive way, to perform recovery on an infrequent but regular basis, sorry, because in this way, this can help in preventing loss of control. One of the best practices, you know, but we also mentioned it yesterday, is to never use cryptographic material from an update to another. Recovery of DID and DID document must be performed in conjunction with the verification method rotation. And the other important point is that, again, recovery is not, there is not a common implementation or common specification of the recovery function. This means that it is up to the implementer to define how to do that. The specification gives us information about the for operation. Is up to the implementer to consider when relevant, and recovery is quite relevant, how to give the subjects way to recover DID and DID documents. The role of human-friendly identifier. If we look at DIDs, DIDs are more or less difficult to be used by human, exactly like IP addresses or other identifiers. So in some possible implementation, the implementer of the whole system can decide to bind these DIDs to simple labels that human can remember and refer to. Nice, but please consider all the possible security feature and consider the system that you are implementing when you add this overlay on top of the IDs. If you, for example, think about DNS that more or less provide the solution to the same problem, you know that DNS is prone to a lot of attacks. So when you decide to not to use directly DIDs, but labels, human-friendly labels identifier, you have to consider also these. Then, if you remember, one of the design goals is extensibility, that essentially provide the implementers the option to add some properties, to add further information to the DID documents. That can be done. There is a particular attention that you have to pay when doing this. Essentially, never add encrypted data in the DID document, especially if your implementation of the DID method is using a public DLT. Why? Because, as you know, encryption algorithms can become less strong with the time, for example, due to increase in computational capacity, or maybe because a flow can be found in his cryptographical course, or because new computing technology can arise in the future. And so you are putting essentially encrypted data on a verifiable data registry that is public available. Maybe today no one can decrypt without permission this data, but this is not always true in the future. So consider not to never use, or at least don't think that encrypting is a solution when you deal with the ID and the ID document. Immutability. This is we talked a lot yesterday about immutability. Pay attention because you have to know very, very well the VDR that you select for your method, or the VDR selected by the implementer of a DID method that you decide to use in your system. Because there are cases in which the DLT, for example, at the root of the system provide you real immutability. Let's say the lockdown is very, very near the DLT technology, but in other cases, some DLTs, for example, use again some overlay or some caching caching solution to speed up writing and reading from these DLTs. And so it's not always true that immutability is, let's say, defined with the strong definition of mutability. I write something on a distributed ledger, no one is able to tamper with the information. So this is something that also you have to consider when you select the root of trust for your entire identity system. Persistence. Again, there are some VDR that really provide you persistence of the information that you write on it. Others, after a given period of time, prune or delete some of the information. This means that, for example, you anchor your DID document to a VDR that after a given period of time prune your IDs, and essentially they are deleting one component of your identity. So, for example, in this case, you have to consider to refresh your with new transaction and to anchor your DID document to the DLT with a given periodicity, because you know that if you do it in time, your information is never pruned. Or in some implementation, you put a small deposit, some small token on a specific transaction. So these tokens are locked in the system. Essentially, you are instructing the VDR not to prune that specific data. So there are plenty of options. There are plenty of solutions. Be careful when you select. That's the, let's say, the underlying ideas of these security considerations. Okay? You cannot only consider security feature of the DID and DID documents as specified in the recommendation, but consider also what is around the core of your SSI implementation. Typically, the recommendation doesn't give you the answers, no? Essentially, we don't have any answers from these considerations, but are meant for us to use our brain and really consider security, the whole security of what we are implementing. Besides security considerations, this recommendation also, and each DID method specification give you specific security and privacy consideration based on their specific decision already made when they decide to specify that particular method. For what regard privacy, for sure, the core specification consider privacy by design since from the beginning. The idea is to preserve anonymity and pseudonymity of the subject, but please consider also some other points. Keep personal data private. Never put personal identifiable information in the ID documents. Essentially for the same reason why you don't have to add encrypted data. So don't put personal information, encrypted data on the ID documents. In some cases, it's very important also not to give exactly the right information to let a peer or anyone else that can, for example, read on a public DLTs, the different DID documents, the information, for example, to classify the subject. In some cases, is a best practice not to let the other knows if we are person or objects or organizations. Okay? This depends, of course, on the specific application that you are developing, making use of a self-sovereign identity. We discussed pairwise yesterday, essentially, because one other important privacy feature is unlinkability. I don't want to be linked by services. That's why, for example, I can do or I cannot do use different DIDs with different verifier systems. Essentially because if I, for example, use the service of system A and of system B, if they collude and exchange information, they can link me. How? With the DID, but not only with the DID. If you remember all the information that we add to a DID documents, I can also be linked based on the public keys, because the public keys doesn't change, no? So it's not only the DID, but also the information that we put inside the DID document can be linked. These are, let's say, the general consideration that we have to take in mind when taking decisions or when implementing a system or when we decide to specify, implement our own method. Any question about this? No. Okay. Now, we go through 3 examples of real-world DID method. Something that is already implemented that you can use. And why 3? Essentially because this is my personal classification. Someone can agree with this classification, maybe others doesn't agree. This is what I think. We can essentially classify the DID method in 3 different classes. The DLT-based method, so all those methods that use a real DLT as a root of trust, web-based method, so method that use the web infrastructure for the VDR, and key-based method that are those methods for static keys. We will see an example, the ID key in particular, where the key is essentially encoded directly in the DID documents. So when I give you the DID, you simply create a very structured and fixed DID document, and you can decode your public key directly from the DID. This is, if you remember the framework, at the bottom, there were all the different VDR and DID methods. And one option was, I don't use a VDR. Using this kind of method, DID key, you don't need a VDR because everything is already inside the DID documents. One more information. Why someone decide not to use DLTs as the root of trust for the framework? Because at the very beginning, DLT was the only option. So the community had this very specific belief, we have to use DLTs. But since the beginning, 6-7 years ago, a lot of different methods has been specified. And so it's very difficult to put people together and decide to work on a specific DLTs, because you want to use a Bitcoin network, I want to use the Tango, someone else want to use Ethereum. So the idea behind people that is specifying web-based method is that there is only one single infrastructure that the whole world is using today, that is the web infrastructure. So don't use DLT because there is not a real agreement and consensus about which kind of DLT we can use. Let's use the web infrastructure. My, again, personal idea is that if you want to build a strong framework where trust is real in trustless system, you have to use a DLT. We will see 3 examples. One of them today, the other 2 next week, because you know, the other 1 hour and a half you will have Professor Azzeni that give you some exercises. So we will see one of them, but at the end we will discuss the differences between the 3 in terms of some indices, performance indices, or feature. And what are the features that let us compare really the 3 different solutions? For sure, how immutability and persistence is implemented in the VDR. DLT can, for example, provide you real immutability at the core of the working principle of the DLT itself. If you want, for example, immutability in web infrastructure, you have to implement further best practice solution to consider let's say, provide immutability or at least integrity check of the information, no? So you have to add some more technologies to really have a sort of immutability. Persistence also. Then performance. you know, when you essentially write and read on a DLT, read is super fast, but writing is not is very slow and cost. When you have a VDR that make use of database, it is exactly the same. Oh, sorry, is exactly the opposite. No? So writing is super fast, reading not always is so fast. So performances, we have to consider these feature to compare the three solutions. Cost. What are the costs that you as an implementer and then the service provider have to consider to run your framework? And the CRUD operation. Because why CRUD operation? Because you should have understood, for example, that with DLT or web-based method, I can update or delete or deactivate the ID document, but for example, in key-based method, since I don't have a VDR and the key is static and encoded in the DID itself, I can't update or delete. So those are the different feature or performance index that we will consider to compare the three solutions. Now, for the DLT-based method, I selected the DID IOTA method. The IOTA foundation that is behind the specification and implementation of this DID method is developing the IOTA identity framework. We at Links also contributed a lot to that framework. We essentially contributed them the zero knowledge proof feature for selective disclosure verifiable credential, and very recently we also contributed the implementation of the post-quantum cryptography based solution for identity. So that's why I selected it, because we know it very well. Now, the ID format, of course, the ID, and they selected the name IOTA. At the beginning, for example, just to give you some example of changes in the specification, at the beginning, we were forced to select only a number of 3 letters. That's changed. Okay, at the beginning was there was a room only for 3 letters to specify the name. Now you can more or less use whatever you want. So the ID IOTA, and then the method specific ID. In their specification, they didn't use this name, but use IOTA specific ID string. The IOTA specific ID string is one more information, IOTA dash network, because you know typically the DLT, the foundation behind the DLT deploy mainnet and testnet. No, so the real mainnet where you don't only anchor your DIDs, but also you exchange tokens, and testnet for other developers that want to make tests and whatever, or in some cases more than one testnet. So they decide, and if to the best of my knowledge they are the only one that decide to add one more information after the DID name, also to specify in which network. And that's very important, because otherwise I don't know which network to contact for resolving the DID. So the IOTA network colon, and then the IOTA tag. IOTA tag is what in DID recommendation is called DID method specific ID. And they, in this particular case, decide to use 64 lowercase hexadecimal. Okay? The IOTA network is optional. If not specified, you know that the DID that you received is a DID that point to the mainnet. So the network, the ID of the network, the main network is that one, 63, 64, ID 5. So these three DIDs resolve to the same DID document. Okay? This is something that I put there just to give you one more, to stress one more, that every single DID method can specify specific things, specific feature. Okay? It is very important that you understand very well that specific specification if you want to use it. So why these three resolve to the same DID document? Essentially because in the dirt one, they are not specifying the net. And so we know that if the net is not specified, we have to, essentially, they are telling us mainnet. They can use the ID of the, instead of the IOTA name of the network, or simply use IOTA, that is the name of the mainnet. Now, a few words on, now we know very well the format of the DID, but we need to understand which kind of VDR we have at the core of this solution. In this specific case, we have the Tango. So this is why the IOTA is a DLT, but not a blockchain. Why? Because the data structure that is stored in a distributed way in each node of the network is not a chain of blocks, but is a tango. For the Italian people, è un cordone. Every single square here represents a transaction. This transaction, every time you made a transaction on the tango, you have to refer to other previous two transactions and check those transactions, verify that the transactions are true, and it works very, very well with respect, for example, in terms of performance from blockchains, because in blockchains, you typically, every single 10 minutes, one block is mined, so it's attached to the whole chain. It contains some transaction that you have validated. And so essentially, your DID document is attached to the network more or less after 10 minutes. With this specific VDR, it is super fast because since the validation of the transaction, every single transaction validated through previous transaction, when you increase the number of transactions in input, essentially you scale because you validate much more transactions. No? In classical blockchains, if you increase the number of transactions in ingress, you don't scale because every single 10 minutes, a bunch of them are validated. So this is also a reason why we like it a lot, this specific data structure for distributed ledger. If you want to consider a parallel, you can consider constant bit rate blockchains and variable bit rates, the Tango, because they scale very well with the number of transactions in input. But what's the problem? The Tango prune the oldest transaction after a given period of time. You have two options. You must refresh your DID documents such that you have a new transaction that store your DID documents before it is pruned, or you can make a small, very small deposit and make your transaction and the data that you attach to the Tango not prunable. Okay, so that's part of the consideration of the security consideration of this particular DID method, because I have to know how the VDR works to build my own ID system. This particular DLT, beside transaction of value, so you can exchange the token, let you make some specific transactions that are called data transactions. So I can really anchor any kind of data to this Tango with a data transaction. And that's how we attach DID documents to these DLTs. Essentially, you make a transaction that have an header and a payload, and the payload contain some metadata related to the DID documents and the document itself. Also, and that's something I like a lot, this is the classical DID documents that you produce when you use the IOTA identity. Look at the ID property. Not only, let's say, the ID of the subjects, but also the one for the verification methods. So they are DID, column 0, column 0. So what? I said from the beginning, I have to put the ID name, the ID name, method name, and then specific ID. And in this particular case, we have 0, 0. Okay, why? This depends on the working principle of the Tango. When you make a transaction, you essentially receive back an ID of the transaction. And the ID method use the hash of that ID of the transaction as the method specific ID of the for the DID. But you receive this ID after making the transaction. Okay? Because if you don't make a transaction, you don't receive back the DID. But you have to prepare your DID document, that is the data that you want to anchor to the Tango. So essentially, they decided for several reasons to put the ID 00 in the DID documents, and when someone else resolve, will use the ID for resolution, they can check that that specific transaction made by the controller of these DID documents coincide with the method specific ID of the DID. They can check. If the check is successful, you can retrieve the DID document, you retrieve the DID document, and then in post-processing, you essentially change 00 with the name of the network and the ID of the DID, such that the peer that resolved your DID have a well-formatted and complete DID documents, okay? But this is a specific feature of this method, and others don't use this approach. So that's why Again, I'm stressing, please, before selecting, you have to know very, very well the method that you are going to use. I told you that more or less in few 2-3 years, multi-key will be the only one used, but they, for example, decided to use, and they only use JSON web keys for verification methods. Among the metadata of the documents, you also have the property created and updated. If I remember correctly, the property created was not mentioned in the slide before because I think the last version of the recommendation decided not to use created anymore, but they are used. Correct? Ah, okay. Good. Okay. Let's make this